Good day everyone, this is Jade C Journals and I will discuss to you the chapter 17 about scheduling. In this chapter, you will learn about the objectives in scheduling, loading, sequencing, monitoring, advanced planning and scheduling systems, theory of constraints, employee scheduling.
What is scheduling?
Specifies when labor, equipment, and facilities are needed to produce a product or provide a service. It is the last stage of planning before production takes place. The scheduling function differs considerably based on the types of operation.
Scheduling in process industries. In process industries, such as chemicals and pharmaceuticals, scheduling might consist of determining the mix of ingredients that goes into a vat or when the system should stop producing one type of mixture, clean out the vat and start producing another. For mass production, the scheduling decision is pretty much determined when assembly line is laid out. For projects, the scheduling decisions are numerous and interested. That specialized project scheduling techniques such as PERT and CPM have been devised. For batch or job shop production, the scheduling decisions can be quite complex. In previous chapters, we discussed sales and operations plannings, which plans for the production of product lines or families. There are objectives in scheduling. First is meeting customer due dates, minimizing job lateness, minimizing response time, minimizing completion time, minimizing time in the system, minimizing overtime, minimizing machine or labor utilization, minimizing idle time, and minimizing work in process inventory.
Once a project plan has been signed off, it's time to move to the schedule. This next step is where you'll expand on the project plan by outlining how the proposed plan dates will be achieved. It's the time to dig into the details, focusing on the activities that will deliver the project benefits and the resources you'll need to achieve them. It's rarely as simple as creating a sequence of events. In fact, it's more like a balancing act. You'll need to manage time, cost, and quality, while still making sure the project benefits can be realized. Different approaches to schedules should be taken for different types of projects. But what they all have in common is a set of core components and a dependency on accurate estimates from the project team.
Have you ever experienced an overdue workloads? Or you cannot keep up with the schedule? If you have experienced those problems, maybe you should do some scheduling in your work. There are so many scheduling techniques used according to the work to be scheduled. One of it is called Johnson's Rule. It is a technique used to sequence jobs in a low-volume system. The functions are 1. To minimize the processing time, and 2. To minimize the total idle time on the machines. If the process is a two-stage unidirectional process, then Johnson's rule technique is used to minimize the make span of the process. What is a two-stage unidirectional process? Okay, it is two or more processes where you have to finish the first process before proceeding to the next process. Let us consider an example. When you want to send a letter, you have to put the folded written letter in an envelope. Then, you need to write down the address. This is called a two-stage unidirectional process. 1. Put the folded written letter in the envelope, and 2. Write down the address. Or you can do it vice versa.
Regardless of their primary scheduling objective, manufacturers typically have a production control department whose responsibilities consists of the working loading is. Loading is the process of assigning work to limited resources. Many times an operation can be performed by various persons, machines, or work centers but with varying efficiencies. The process of prioritizing jobs is called sequencing. If no particular order is specified, the operator would probably process the job that arrived first. If no particular order is specified, the operator would probably process the job that arrived first. This default sequence is called first come, first served. If jobs are stacked on arrival to a machine, it might be easier to process the job first that arrived. Last in is now on top of the stack. This is called last come, first served sequencing. Another common approach is to process the job first that is due the soonest or the job that is the highest customer priority. These are known as earliest due date and highest customer priority sequencing. Operators may also look through a stack of jobs to find one with a similar setup to the job that is currently being processed. That would minimize the downtime of the machine and make the operator's job easier. Variations on the DDATE rule include minimum slack and smallest critical ratio. Slack considers the work remaining to be performed on a job as well as the time remaining to perform that work. Slack is equals to due date minus today's date minus processing time. The critic ratio uses the same information as slack, but recalculates the sequence as processing continues and arranges the information in ratio form. Mathematically, the critical ratio is calculated as follows: CR equals time remaining over work remaining equals to due date minus today's date over remaining processing date.
And this video demonstrates the critical ratio. The critical ratio is just a way to evaluate the progress of our jobs. This uses data from problem 15.11 at the end of chapter 15. We have 5 jobs here. They're given job numbers 103, 205, 309. These are the due dates for those jobs. This is the duration, the number of work days that we have on that job. Here it's kind of interesting. They tell you that they received all the jobs assume that all jobs arrived on day 180, but today's date is 200. A lot of students think that we've been working on these jobs, but we haven't. So just because we got all the jobs on day 180 doesn't mean we've been working on them. So starting with today's date, so the key is the 200. So we just kind of ignore the 180. So the 200 here is what's important, is that starting today, we're now going to start working on these. So we need to know how many days we have left, time remaining compared to how long we think it's going to take us. And so the key to this is simply to take this amount and subtract today's date. We want to absolute that. And then we can copy that one down with it absoluted. We can double check that it's copied correctly. So we'll double click on this one. It takes the due date and minus. So there's 19 days remaining, but there's only 5 days. Now the critical ratio is calculated. This formula is provided to you on the formula sheet. It's actually a pretty simple formula. On the formula sheet, the critical ratio, CR, time remaining divided by work days remaining. The key to this formula is understanding the difference between time remaining and work days remaining. This is the time remaining. We have 14 days, and this is the work days. So you can see that in most cases, I think all these cases will be above 1. If the number of days that we have to work on this or it relates to the number of days we have left, you'll get a 1. Anything above a 1 is good, meaning that you have more days left than you have work to do on that project. But we can assume no work was done on these. We're doing the work now. So you simply take the time remaining and you divide it by the duration of the project. And so we now can copy this down. So in this case, it looks like, if we were to rank these in orders of priority, we have nothing below 1. That's good, meaning that we have, days remaining and less work than we have days remaining. But just to schedule things, we're going to pay close attention to job 517. That'll be first. Then 103 will be 2. Then 309 will be 3. This will be 4. Job 205, and the least we're at least worried about 412. And that should make sense. We have 19 days left and only 5 days of work on this project, so we could probably pull some resources off this and put to some of these other projects, but really we don't need to. We just need to make sure that this continues to progress the way we want it to, and so we'll watch this closely because we actually have more days left than we have work days, and that's all there is to critical ratio. Pretty simple technique.
Gantt charts are used a lot in project management. But have you ever wondered where they came from, what they really are, and how to use one? In the 1910s, a management consultant and engineer, Henry Gantt, devised a chart that showed not only what tasks need to be completed when, but also the start and end timelines for each task. As this has evolved over the years, the Gantt chart now also shows interdependencies of tasks, highlighting for everyone involved in the project what needs to be complete before something else can start. A Gantt chart is a graphical representation used in project management that will show the length of time tasks in the project should take. This helps the project run more smoothly because you can easily see the order of tasks. You can see project progress in terms of where you are and where you should be, because each task is given a time allotment. You can see both the start and finish time of each task, showing where it is possible to have things happening at the same time, which helps you plan resources appropriately. You can see any interdependencies that exist between tasks, i.e. which tasks you have to complete before you can start others. Not only will this help with the planning phase of the project, where you must decide the course of action to take, but it will also help you monitor the project and keep it on track. When you set up a Gantt chart, you'll need to think about what needs doing. Create a task list. Who is responsible for each task? How long will each task take? What problems might you face, and make sure you build in contingency time? Which tasks are dependent on other tasks being completed first? Now you have a clear idea of the order of things, you can start filling in your Gantt chart, showing the order of activities, where things can happen at the same time, and where one task must be complete before others can start. Once you have the Gantt chart designed and agreed by everyone on the project, you can use this one document to keep your team, stakeholders, and anyone else interested informed of progress. Simply update the chart to show schedule changes and their implications, or use it to communicate that key tasks have been completed. Like every tool, there are pros and cons to the Gantt chart. It can be time-consuming to keep updated. Overall, compared to the more basic list of tasks with a deadline assigned to them, the Gantt chart offers you great advantages, which have been realised by all types of business for all types of projects.
These two are not just equations of accounting, but also the guiding mantra for managing companies. Mathematically speaking, these are linear equations, which means that the net response of a system of many parts is just a sum of responses of individual parts. So if we focus on managing the parts independently, we get an additive output. This conceptual approach is put formally into play by breaking down sales into product categories and territories, and overall costs into various cost heads, and setting budgets for each component, which are then divided amongst managers as targets. Adherence to targets is used not only to manage and control, but also as performance incentives. Simple, isn't it? Unfortunately, it's a little too simple, and like Einstein said, everything should be as simple as possible, but not simpler. There lies the trouble with such oversimplification. An organization is a system of connected entities working together to deliver goods to customers and earn profits. As a result, business variables in the real world are highly interdependent. An action that changes one variable could impact another variable in the chain, which might impact yet another variable, and so on, eventually boomeranging back on the original action. For example, the decision to increase sales can lead to growing inventory levels, thus increasing working capital levels, which can force one to increase supplier credits, causing material delays and hence production delays, which can then finally impact sales negatively. In this non-linear world of causal loops and relationships, the linear mathematical equation is not applicable. Here, a big action can result in no outcome at all, or a small action can result in a big outcome. And imposing linear models of analysis and decision-making on such systems causes severe damages. Actions taken on one variable can impact other variables in the system and create operational conflicts within departments. And then, remedial measures have to be taken on the first action. Management's capacity is exhausted in managing short-term conflicts, dramatically slowing the organization's ability to deal with external opportunities and threats. This approach clearly does not work. We need a systems approach to manage a complex organization. It is a deeper understanding of causal relationships between parts. These interconnected systems look complex, but are inherently simple to manage because they always have one single leverage point for intervention. And finding this leverage point for a focused intervention is the only way to manage a complex organization.
Thanks for watching.